Hi, everybody. Welcome. Welcome to Harnessing Imagery, AI, and GIS for Smarter Decision Making. I'm Dan Reus of Openly Disruptive. I'm happy to be your moderator for today's session. We're really excited to get this kicked off. Just a few things to get us going. We have some great speakers lined up that are waiting backstage for us. They're listening in. Special thanks to our sponsors. If you have questions during the presentations, please put those in the Q&A box. And the chat is where you can find all of the housekeeping notes and everything for this session. But the session is going to be great. We've had a few conversations already, and I think you're going to be pleasantly surprised by the depth of conversation here. We're going to hear multiple points of view on how to use all of this data that we're getting these days to deliver better services for our stakeholders and our communities. Um, I am I'm pleased to announce this. We're going to have Easton is going to join us from Samsara. He'll be kicking us off, followed by uh, um, folks from Hudson, Ohio, to share how they use what Samsara does with IoT data to better take care of their citizens. And then we're going to go and take a look at some things from a transportation perspective with Sam and Samantha and Nick. So we've got a lot of things to cover. I want to get into it right away. So I'm going to go ahead and introduce Easton Archibald. Easton Archibald is with Samsara, and
Ann?
Sam's, yes,
And this is Ann. I'm the MC or the moderator here. I just want to throw the poll up real quick. I'm going to throw a demographic poll up.
that is correct. Ann had actually told me about that in advance, and I neglected that. So um, there's a poll, please. It helps us to know where you're coming from and what your interests are and everything. It helps us to make sure that what we're doing today is as topical as possible and helps us plan future events. Um, and The webinar will be available on demand after this, so you'll be able to share it with other people. Um, I encourage you to listen to what Easton and all of our other presenters have to share, and share your questions. You can put them in the Q&A box at any time as we move forward. We've got plenty of time in the schedule for lots of questions and talking about what's important to you. But beyond that, I want to go ahead and let us get started. So once again, Easton Archibald. Easton is a sales engineer with Samsara. And Easton, take it away.
Hey, thank you, Dan. Appreciate the intro there. Welcome, everyone. My name's Easton Archibald. I am a solutions engineer at Samsara. Also, have a background in environmental engineering. So I found a nice home here at Samsara, helping public uh, municipalities work through their operational challenges. And yeah, today we're going to be talking about the way that Samsara and this data that you can collect can be used to connect your services and your community. So we're going to kind of take a quick look at what Samsara does. First, to start, if you haven't heard of us, we've been around for about 10 years. We are built to improve the safety, efficiency, and sustainability of the operations that power our global economy, and what I like to say is our public operations as well, because we're definitely a large part of it, right? So Samsara is a huge platform. We certainly don't have enough time to walk through everything, but this is just an example of some of the data that Samsara collects at a high level. Predominantly, we're a safety and AI dash camera company that does vehicle tracking and telematics very, very well, but also connects other aspects of your operations, right? Think of it as a connected operations platform. So you can see we're collecting vehicle data, equipment data, assets, things with workflows. Think about like mobile forms, et cetera, and then alerting on those things to make your life more efficient. Today, we're mostly going to be focusing on the data that we're collecting from vehicles, equipment, and see how some of that safety aspect ties into it. So just at a high level, if we kind of step back, your public organization, you have goals, you have sustainability goals, you have carbon emission goals, you have safe, I don't know, other organizational goals, right? And it's a matter of how do we create those goals, how do we action on those goals, and how do we communicate those goals that we made and we're telling the public what we're doing, right? So this is kind of what this chapter, this presentation is all about. And how do organizations meet goals? Well, it really comes down to how do organizations make decisions in groups. And if we kind of walk through the structure of how folks make decisions in groups, smaller municipalities, they have a very fast decision rate. They may have one decision maker with a number of contributors, and they can all huddle up in the same room and get to that decision very quickly. As soon as your structures start to get a little bit larger and your organization style becomes more complex, that decision rate drops. And you can imagine for larger organizations with multiple decision makers, contributors from all over the place, it's very difficult to kind of get that decision out and action on those items very quickly. So on top of that, how do organizations connect with the public? You have your decision making, you understand that it goes much slower as you move forward. It's kind of the same story with decisions, right? Like if you have a huge municipality, it doesn't really matter how great your public outreach coordinator might be. It's just very difficult for that person or that team to gather all that data, connect with the public in an effective manner through bulletins or even a web page. So it's really a systems problem. You can't really adjust what your structure of your government looks like. And so you need to kind of manipulate the system and look through a single pane of glass to be able to make those decisions and communicate effectively with your citizens. So just as this kind of graphic shows, Samsara is all about flattening that data and providing transparency internally to make decisions quicker and externally. So we just have to give the data to the people. It's kind of as simple as that. This presentation is not about how Samsara has great flexibility with permissions, et cetera, but it's more just how can we use that to drive decisions. So I'm going to kind of walk through a couple of the examples that our customers have used Samsara to get this data to the public. And then we'll hear from one of our current customers, City of Hudson, afterwards, how they were even able to gain additional insights and improved efficiency in their operations. So this is City of Lawrence, Kansas. We're going to walk through these maps sort of as rudimentary to sort of medium complexity and then highly complex with a large scale customer of ours. This is like a snapshot of City of Lawrence, Kansas from a snowstorm that they had over about that week of March 13th to March 20th this year. And the orange lines you're seeing here are all the plow locations. So it's pretty simple. This is one that's sort of pre-canned out of the box and a great way for cities to just create something quickly. They're already tracking that data. It's literally as simple as clicking a couple buttons saying like, yeah, I want to share these vehicles. Yeah, pump it out. All right, let's embed this on our website. And now citizens can see what's going on. From there, that really allows cities to gather that initial feedback instead of trying to build this like complex, beautiful web platform right off the jump. You can just start small and iterate quickly. Getting back to the idea of making decisions fast, it's important to just action and iterate on that just as you would in a startup. So this is City of Lawrence, sort of that simple one. The next one we're going to talk about is the City of Syracuse. So they were one of our first customers to make sort of an advanced snow integration and public-facing map. And initially, there was a lot of concerns, and a lot of the concerns I hear from speaking with customers is, well, if we put this data out, we're just going to get more calls. We're going to get more, problems, basically. Like, we're going to get more questions. Why didn't you come down my street? What's going on? Like, why are these plow trucks over here? But after City of Syracuse measured that first year that they had this map published, there was a 30% decrease in citizen calls with this custom integration. So it was providing that data transparency directly to citizens, allowed them to reduce their operational time that they spent dealing with citizen calls, and they were able to effectively maneuver those resources to deal with what the problem was. And Syracuse is one of the snowiest cities in the United States, and surely they need all hands on deck when possible. So this is one that they built with Esri. This is what their map looks like. And a couple of things here. So we have like all the blue lines. It's sort of similar. You can think of it as a leveled up basic Samsara one. They also have these sort of splitters, right, where you can see like, this one was done less than an hour ago. This was within 3 hours, 6 hours, 24, etc. But what I want to call your attention to is the like formerly siloed data that we had before with this illegally parked car location. Now, we know snow operators aren't spending their time giving out tickets, getting out of their plow and saying this is an illegally parked car. This data is combined from their traffic enforcement and notifying both themselves internally, hey, we need to go remove this car, we need to get PD involved, whatever it might be, and provides those decisions quickly. And it also provides the public that data transparency from previously siloed departments where, yeah, okay, maybe the front of my house didn't get plowed because my neighbor decided to leave their car out. So I kind of got the short end of the stick, and that was the reason there. So they have some more information you can click into. I mean, they made this one really smooth. You can click on the route and see the time it was last serviced, etc. And then here we can see those clumpings of cars in this neighborhood, right? So moving on to sort of a larger scale operation, we mentioned earlier Samsara does safety and AI dash cameras and keeping employees safe. Well, if you're already collecting this safety data, that means you're already collecting video data, which means videos are just a bunch of pictures. And Samsara has the ability to basically take these stills and then push those still images to a large map. And at first, it's sort of a weird idea because it's basically providing like, I don't know, like live feeds of these vehicles, not necessarily live like in cab, but video snapshots or rather stills of what's going on. And it's kind of hard to see like what that impact would be. But when you scale this up over a very, very large area like Oklahoma DOT, you're able to see like, oh, these are actually just networks of vehicle cameras providing real-time screenshots essentially to citizens. So if I was living in rural Oklahoma, which much of it is, and I needed to get to the store to, I don't know, get baby formula or some emergency like that, but I don't really know what's been done and exactly what it looks like. This additional information contextually can be very important to make those decisions for yourself and for your family. So that's really all I had to chat about. I think the ideas really are just flatten the curve, flatten your decision making, have one pane of glass to drive decisions internally, and then provide that to your citizens because they'll appreciate it. Everyone's used to living in this sort of real-time data mode anyways, and you're already collecting the data, so you might as well do something powerful with it. Thank you for your time today. I think we'll be bringing on our folks from Hudson. I'll let them introduce themselves.
Hi, good afternoon. I'm here with my colleague, Paul Leedham. We're going to talk to you a little bit about the city of Hudson and what we've done with some of the Samsara equipment that we have in our vehicles. Kind of started off with looking at our programs. We had a vision of how would we make our programs better. Historically, we managed these programs with a lot of labor. There was a lot of data that needed entered for our snow and leaf collection operations. We'd collect this data with people sitting, monitoring radios, people bringing back data as to where they were throughout the day. This stuff was entered into to various platforms, mapping, so on, so we could let the residents know what has been done. After we got the equipment installed in our vehicles, we looked at, is there a way we can integrate this with some of the AI type softwares to automate these systems and make them work a little bit more seamlessly. We had to look at the hardware end of things. We had to look at the software end of things. On the hardware end, we had a few different types of equipment to deal with. One is our leaf collection operations. Other would be our snow operations. On the leaf collection, we had to come up with a way to trigger this information to get it to feed into the devices. The device they have various inputs, and there's also a digital type input form as well. So on the leaf operations, we had a manual type trigger that would start collecting the information. On the snow operations, we had basically we had to make a cable. We had to develop some hardware to interface our snow equipment with the device. Once we got this stuff put together, we worked with our IT folks, Paul. We gave them kind of our vision as to how this would work. And then Paul started working through how to make this a reality. I could let Paul speak a little bit on how he put this information together and got it to our forward-facing maps. Paul?
So yeah, so good morning. I think it's morning for most people. Good afternoon for the people on the East Coast. We, as Kevin mentioned, we are we're from the city of Hudson, which is in Ohio, just to kind of give you a frame of reference. And we do have a lot of leaves, and we had a lot of snow. So this is a problem that we've been wrestling with for several years, actually, ever since we became a city. So I think it was Kevin is our new public works director, and I think with the partnership that we put together in order to try and solve these problems, we teamed up with a consultant that you just heard from a few minutes ago, and we started to really figure out ways that we could solve the problem. You know, how can we provide the residents what they want to see in an application that is helpful, but not only that, it's something that's going to save time for everybody within the city to do their day-to-day operations. And we tried lots and lots of different things. We really did. So I'm going to show you a few screenshots of the process that we went through, just to give you some of the technical perspective, and then Kevin and I will just kind of jump back and forth to explain how we did and why we did specific things along the way. It really was kind of a process that we went through, and we figured it out as we went along, which was kind of fun. So let me just share my screen. So this is what we started with. Essentially, this is just this is the data that's put out from the API that we used, that's gathering data from all of our trucks that are out in the city, just doing what they do. This data was coming from our leaf vac, actually. So what we needed to do to begin the process was to write a mechanism that could encapsulate this information, pull it into our systems, and actually, ultimately, what we're looking to do is to put it on a map. So this is what we started with. As you can see, just it's an API, it's the response from the product that we were using. Then we took Visual Studio on Python, Python is a development tool that you can use to do all kinds of things. If you guys are GIS folks, you've used Python, I would assume, or at least you install it whenever you install ESRI products. But this is essentially what's happening here. This is a way that we go. It's a listener, essentially, that goes and pulls this information from the API, and it pulls it directly into our SQL Server database. And it runs every 5 seconds is what we designed this program to do. So there's a lot more code to this, but this just gives you a look to what we were building. So once we got it into the system, into a database, an SDE database, essentially is what we're using, we could start to then use methodologies, GIS methodologies, to drop points on a map. So this is the beginning of doing that here. Then what we were able to do is we generated a map service that would project those points dynamically onto a map through our REST API, where we were able to then project a map that we could consume through several different formats, several different maps, or however we'd want to use it. But we dropped it through a REST API here. As we were investigating different ways that we could put this information onto a map, we were looking through the processes of building a custom map ourselves, or looking at some templates that we were able to use through ESRI. And we ended up, this was one that we tested. I think it was a simple what's the version of this called? I think it was called the I can't recall off the top of my head, but this was one we actually didn't go with this one. This was just to drop it on the map. But what you can see here on our leaf collection, this is the template that we ended up generating. The original vision was to actually drop breadcrumbs on a map whenever we had staff that were out in the field collecting leaves. And as you can see here, maybe Kevin, if you want to just discuss why this is kind of the vision that we had to actually put it out there to the public. So
yeah, that's great. Thanks, Paul. So to kind of speak to this map right here, this is a more refined version of what we started with. Originally, when we would start using the trucks for the leaf collection process, this is a new process for our guys. So there's a learning curve for them, and there's a manual switch that they'd have to initiate when they were collecting leaves. And with anything, there's human error, and some people would forget to maybe turn their switch off, or they may be transporting from a location to another, and the switch would still be on, or if they go to the dump site. And this created kind of a map with a lot of noise on it, if you would. So we went back, we discussed this with IT. They started putting in some filters, if you will. We started putting in some geofences. So when we go anywhere outside of the city to, say, a dump location, or we're at the shop, or anything along those lines, it's not recording those locations. Then also to kind of filter out if they accidentally forget to turn off the switch, Paul had created a speed limit. So if they're going beyond a certain mile per hour, it quits recording. So that gave us, where we're currently looking at, we're starting to see a lot more dots in confined areas. Now, the way the mapping is set up, where we drop these breadcrumbs, they're dropped every so many seconds. And if you look in certain areas, you'll see a more dense version of dots, and that tells us there's more leaves there to collect. That helps us for future planning, for allocating crews to go to certain areas, because we know some parts of the city are going to participate more than others. And this helps us to allocate our resources and stuff. We kind of roll this into the same philosophy with our snow clearing operations. To give you a kind of an idea of our demographics, we're about 23,000 people, 25 square miles. We're on the fringe of the snow belt. So the northern part of town gets a lot more snow than the southern part of town. We're about 260 lane miles, and we go through about 14,000 tons of salt, and we collected 18,000 cubic yards of leaves. So there's a lot going on in those two seasons. The leaf operations last about 6 to 8 weeks. And snow, some of us joke around, say it lasts 4 to 6 months, just depending on the season. So this map, it gives us a nice forward-facing feature for the residents. And as we heard before, this has drastically cut down on residents reaching out, asking if we've plowed their road. They can simply go there and see, based on the time, based on the color coding, as to when they were last past their residence.
Right.
On the other hand,
from the residents' perspective as well, I think it's, one of the things that we always wrestle with whenever you're doing leaf collection is everybody wants to know when the truck is coming down their street. And I think it wasn't until this year where we were able to use this technology to show them, no, we are literally coming down your street as of right now. And I think we got so used to, hey, you're going to be out tomorrow, you're going to be out the next day, and our process to collect and gather this information was really antiquated. So it wasn't doing what we needed it to. This breadcrumb the breadcrumb approach was really effective, because if you see red on here, it's coming down your street. And I think that was the important piece. And that was really well received from our residents. So I think, just as we kind of did, as Kevin mentioned, we transitioned to the snow app, because we built the same framework to gather this information. But we had a few different challenges here. Whenever you're doing snow removal, you're really going slow, and the equipment is going at a really slow pace. When we switch to do, as you can see on this map, this is part of the process that we use on this map to figure out the cadence of how we wanted to collect data when they were throwing down salt. But the same basic idea was, the same vision was there. We had this vision of dropping breadcrumbs. The difference is breadcrumbs in this case are actually when they're putting salt down on the street. So I think, Kevin, that was another thing that we wrestled with too, because you can have snow trucks driving all over town, and many people just assume that if they see a snow truck that is putting down salt. In this case, what we wanted to do is be careful that no, we want to show where we're putting down salt. So, Kevin?
Yeah, no, that's accurate. I mean, we tagged these breadcrumbs basically off the spinner function. So, you could have your system armed and ready, but until you're actually distributing salt, it's not recording your location or movements.
Right. And you'll see on this map, it's the same basic template, but the activity is a little different. We went through the same process. We gather all the points, we put them into a dynamic map service, and then we just go ahead and we symbolize the points due to what the time frame was from now to the previous 30 minutes, the previous 60 minutes. And then so to actually put a map together, if you look at it like this, it's pretty boring. But once you get to some of these types of images, then you start to get a really good gauge of where are the active areas, where are the areas that have not been hit. And I think as you zoom in close, you can see that same mindset of breadcrumbs. And then if we get to this one, this is what our council members and a lot of folks want to see. They want to see every street has a color on it. So even though the time frame is what's shown here, you can see on this map that that every street in town has been hit, and you can see where activity is the most recent. So anything to add with that, Kevin?
Yeah, Paul, one of the lessons that we learned from this was we actually changed our durations on the time to give us more, basically a broader scale of colors over a 24-hour period. And then the other thing that it helped is, we were always getting those calls from or emails from council members asking if we've been in this area, when are we going to be over here? And by implementing this map, we have a process where we send out a snow team update to council and the administration. And this map now is included in there, a screenshot of it, just to give them the recent update as to what's going on, the number of guys in, and what's been covered in the city.
Right. So I think just to kind of finish the discussion, and we can move on to the next one, is what we did even in the process of our snow season. We did analyze the people that came to use this application. We got a lot of feedback from folks. So even in a small window of like 3 or 4 months, we did actually have our second iteration. You'll see right in this case that we redid this application during the process, that we actually started to incorporate some additional things, not only as Kevin mentioned, that we did the different timeframes, but we also added weather on here too. So folks within the city itself could start to see where the snow is coming. Where you'll see on here, there's like a bunch of, it looks like pixels. The next app shows that a little clear on here. You also see this is 2.0 up here. But as you zoom out, you could start to see areas of in this case, you've got some high density weather is coming our way. So all the crews could be prepared for in the next hour or so. We know we've got some significant snowfall coming. And then we could zoom all the way out using the Esri products to actually just see on the satellite side of things where it's coming from. So I think just to finish this up, Kevin, if you want to just talk about how we can, after gathering all this data, keeping it in our databases, how we can use this for some of the things we've got coming next year and next season. So.
Yeah, that's why I alluded to earlier was, just by the breadcrumbs, as you can start focusing in on those, you can plan your resources out for various areas, for whether it's leaf collection or snow operations.
Right. Yeah, because we have data for every month, every week. We have those high density points that we can start to do analysis of how, the end of November looked this year in comparison with next year. And I think that stuff's going to be really helpful as we get ready to plan for the next season. So, all right, I think that's it for our presentation.
Yeah, we're going to welcome Samantha and Nick next.
Thank you. All right. Good morning, good afternoon, everyone. Pleasure to be here. My name is Samantha Galltin. I'm with Russell-Kroese Partners. I have along with me Nick Powers from Common. So I'm gonna kick our section off here. So just a little bit of background about myself, just as it kind of ties up and makes everything very pretty in a bow as to what we're going to be chatting about. I started my career with the BNSF Railway for 13 years. At the tail end of that, I started working with our ports on our network. And in 2020, I took the leap to go actually join a port, the Port of Long Beach, and ran their commercial operations bureau. So ran the operations at the port, took a sidestep into green startups, and now doing rail consulting with our port complexes. And so I say that all to say is having that experience with the ports, being in the communities, but also in the municipalities. We saw a lot of data that was needed to really get better visibility for our supply chain. And I know during our crisis, our supply chain crisis during the pandemic, supply chain became this like tabletop conversation. Everybody became a supply chain expert. And really what supply chain and transportation used to be is like these ninjas in the background. We got your stuff to you, and you never knew what was going on. But what we saw with that disruption was this really big, huge need for better visibility, better data utilization, and what we could use with that data to be more efficient, but really call out like what is going on, how do we fix it, and how do we try to get to a place where we don't have those bottlenecks anymore. But even apart from how things actually go through the supply chain, we really start to see like how can we use data to be better community partners, right? Especially at the Port of Long Beach, but also like with trucking and with railroads, we're all in those communities. How do we use data and how do we use that visibility to be better partners in those communities? So Nick, if you could go to the next slide. So what we wanted to show you was just how much data there is that goes into the supply chain, and like where does this all come from, and then like how do you actually use all this. So what this slide shows you is really like all of the different APIs, EDIs, and things that could go into just moving one container of goods, whether that be a 20 or 40. And you can see it comes from all different places. So like, why again are we talking about this? And let me give you a kind of an example of like where these complexities kind of come in. So as you can see, like what a container does, comes off the ship. What I'm in Long Beach or in the LA area, so I'll use the San Pedro Bay complex. So it comes off the ship in Port of LA, Port of Long Beach. So you're going to see like when did it come in, how did it come in, where is it stowed, all of those types of things. Oh, let me try to get a little bit closer to the mic if you guys can hear me okay, hopefully. So then we have to see the custom clearance. You can see where it goes out of the gate, whether it's via the railroad or via the trucking, things like that. Then you have, again, the custom release, in-gate, out-gate, and then going back towards where it's going to, you have the same types of data feeds. So all of this stuff and all these different competing people or stakeholders inside of the supply chain. Everyone has different goals. Everyone is trying to do things, and it just becomes basically a mess. And so at the ports, what we really tried to do is say, okay, listen, how do we get all of this data combined and in one place for our stakeholders, whether that be the people who own the stuff in the box, the people who are trucking it, the people who are railing it, and then also people in the communities to see how much stuff is coming in there, when can I expect it, and how do I plan my resources? And that's the biggest part at the end there is how do I plan my actual resources? So the second example I would say is kind of coming away from the ports, but as soon as that container comes off and gets onto the truck, how does that truck move about inside of our communities? And that's another thing of like dispatching, making sure that it's efficient, so it's not just dwelling in a lane or outside of somebody's house or anything like that. Again, using that data to better get our resources together, but also so that we can dispatch trucks in the better way to make sure that they have appointments, all of those things. Another way that we can use data better to be better partners inside of our community, but also then to get those resources in the right place. The last thing I'll say is I know that I feel like supply chain as a tabletop during the during the pandemic is kind of coming back as a tabletop with tariffs, understanding like, are we going to have stuff on the shelves? Are we going to have, some type of supply chain crisis? And so I know it's back in the news again that, we've gotten a bit of a reprieve, a 90-day reprieve. But now what we're dealing with is, are we going to have this surge with goods coming in again? And the answer is yes. How do we deal with that? Again, it's with these types of pieces of data. Nick, can you go to the next slide? So when we look at that data and how to plan for that next surge, it's going to be this. It's translating all of that data so that people can get the answers that they need. So again, if you put all of those things that are on the screen, you can actually answer, where's the container? Did it go through customs? How can I pick it up? What's the fastest that it can unload? What ship is it on? What terminal is it going to go to? And again, can I plan the resources that I need to effectively move the cargo that I need to move so that we don't get the bottlenecks that we had from the last time? And if you'll go to one more slide, Nick. And this is one of my favorites because this guy is looking like, there's a sea of containers. What the heck am I going to do with all of these things? And what we've seen when we're going through this process is just, there's so much friction in the data. And all of that data is cost, right? That's cost to, the ports, it's cost to our stakeholders, it's cost to the community, because you just have to have all of this stuff to be able to move things the right way and most operationally efficient. And so secret sauce here, Nick and I have worked together in the past to really try to get this friction out of the supply chain and out of the data so that we can actually make it useful. So I'll pass it over to Nick now to get some of that insight.
Yeah, thanks, Sam. Thanks for helping set the scene and load me up for a great ending here. I'm Nick Powers with Uncommon, a consultancy focused on guiding the defense logistics and technology sectors through transformation and complexity. Over the past 15 years, I've worked closely with logistics leaders like the U.S. Transportation Command, the Defense Logistics Agency, and the Department of Transportation, who oversee billions of dollars of supply chain movements. These organizations enable the United States to project power globally, and no other country has a logistics backbone like ours. Why is it so unique? Because it depends on local, municipal, state, and federal governments to execute in collaboration. It's not just a private industry-driven system. So as you can see from what Sam kind of walked you through, port operations are complicated. Integration of technology in the port is hard. Integrating even all of the data together is even harder. And when you look at other things like Samsara mentioned, we can do some amazing things with IoT, and IoT is all over ports today. And that helps with our fleet management. The city of Hudson was talking about how they use that IoT and those other advanced analytics to develop and deliver better services. And that's what we're trying to do by integrating this data and drive that optimization in port operations. But as someone in our audience today, you're probably excited about everything we're talking about, but also maybe a little concerned about how you might leverage this technology. And I'm kind of going to take us a little bit of a 90-degree turn, because I know that you are not alone and it needs to be discussed. And so what I would like to recommend before we get into kind of that, awesome technology piece is for people to think a little bit more about an architecture first approach. I think this is a valuable conversation to have today, because as all of this technology is coming together, it's really hard to try to integrate it with our organizations. So what is an architecture first approach? It's taking the time to analyze your existing systems, documentation, and business needs, discussing your challenges openly, and working as a team to develop the future 2B version of your organization. By doing this, you provide a blueprint to your technology implementation teams, which will reduce time, cost, and increase the quality of your deliverables. So let's think about it for a second. Ever tried making chocolate chip cookies without a recipe? You can assume that you'll need chocolate chips, flour, and sugar. Mix them together and stick them in the oven, but you know it's not going to turn out the way you expect. You can continue to experiment with oil, butter, baking soda, and other ingredients until you came up with something that resembled the cookie that you would actually eat. But this will take additional time. In both these examples, you probably end up wasting money on misguided culinary experimentation. This is exactly the same thing that happens when you try to change processes and implement new technology in your organizations if you don't have a recipe for success. So just like baking cookies, having a recipe for technology implementation is necessary. These recipes can enforce standards, SLAs, map out how processes will change, and establish how the organization will govern and measure success. For you, I offer a way of getting to that blueprint pretty easily, and that's through the Unified Architecture Framework, or UAF. It's an overarching standard that can help you develop these artifacts. But I know this can seem intimidating. So for the purposes of talking about how we work through integrating data at the port, I've kind of broken into 3 core areas. First, we worked on developing a list of all of the connections, stakeholders, interfaces, data flows. It was incredibly important to map this out. And to relay it to maybe say like a local municipal government, what I would say is when you look at implementing a solution, especially one that implements AI or ML or LLMs, you're going to need to think about who's going to use this solution, who's going to maintain the solution. Are you going to use user interfaces or API connections? You know, how are you going to administer, maintain, and keep this up to date on a daily basis? Who's going to pay for it? And how are we going to make sure the connections that you're using are secure? These things are all parts and pieces of the artifacts that you get to create using an architecture first approach. Then we looked at consistency. How will the stakeholders use our solution? You know, in the port specifically, we had terminal operators, we had the stevedores and unions, we had ocean carriers, we had rail companies, we had trucking companies. You know, there was a ton of stakeholders involved here, and we needed to make sure that the results that we provided to these stakeholders were consistent. And so a big part of that is messaging and training and making sure everybody's on the same page using the same nomenclature. You know, when you look at all of those different EDI transactions, they're actually in a bunch of different formats. I guess when I say formats, I mean there's different fields required between the different EDI transactions. And within those fields and formats, you actually have industry-specific things that are required. And as a result of that, the translation of that information across these different formats, industries, and things like that are incredibly hard. And so making sure that we're all on the same page across these industries and across these service lanes was really important. And finally, how we had to think about data privacy. We had to think about ethics and regulations that are being applied to the use of this information. In particular, we're worried about FOIA and sunshine laws that could force us to reveal information that was very precious to the users of the port. Finally, we had to really think about accountability. This is a big problem for public entities. How you make sure that you comply with local, state, and federal regulations. How are you measuring and controlling your system so you know the right people have the right access and the wrong people do not. And as you change your solution over time or increase capability, you need to make sure you're updating your documentation, including all your interface diagrams and things like that. Update your training to reflect those changes and make sure that the controls that are in place from a security and a governance perspective are also being changed and updated as you go through that. Leveraging this approach and Common helped bring together hundreds of stakeholders at our port customer, integrated their data, and are currently processing over 1 million transactions a month while providing advanced analytics through dashboards and sharing data with our port partners. You know, so when you start looking at the impact of some of these new products that we're having, you know, how can AI, imagery, and GIS drive smarter decision-making and logistics? We're seeing that impact today. You know, I talked a little bit about the translation problem that we have. Well, large language models can actually translate that data, put it in a similar nomenclature, and kind of reduce those barriers to entry as you're trying to get through that information. You can also intelligently parse through different disparate data and data formats and pull that into the same field and format. AI can sift through bad data. We also call that noise. and also surface the golden transactions for faster, more accurate decisions. You know, when I worked with the Army a few years ago, specifically for ocean carrier movements of our military logistics equipment, you know, it was really hard to figure out where that equipment was on any given day because I would get hundreds of transactions a day on one specific container movement or piece of equipment moving. And the reason for that is the way our standard is there's no real easy way to update data on a specific field. You have to resubmit the entire transaction with that updated information. And so finding that what I call golden record or golden transaction is really hard. And without that golden record, it's really hard to make accurate decisions. And so leveraging LLMs, AI, and other things like natural language processing, we'll be able to do things that we've never done before, mine chats, logs, and transactions, and optimize our cargo flows. Computer vision is also picking up steam in the ports. We're pretty excited about this specific area. We're seeing this in the field, and in fact, Uncommon is implementing a computer vision project for one of the largest ports in the country. With this particular project, we're working with rail operators to use computer vision to track the movement of engines and cars. And as you can see here on our picture, we have little blue boxes around some of those container numbers. And what that does is those container numbers are actually how you track the cargo as it's moving across the country over the ocean on rail and truck. And so if you can geolocate where that container is at any given time using that container number and your geo-positioning, you can actually report on where that is. That gives us a lot of great time to prepare for those containers to arrive or depart a given location. Additional use cases being tested today, including informing security teams of unauthorized access to rail cars and containers. So we can actually, through the use of computer vision, determine when a rail car has been opened. If someone is moving in and out of that rail car, we can determine if they've opened a container. This is all incredibly important for the security of our supply chain and the transportation of our goods back and forth through various locations. Port managers are also leveraging computer vision to monitor the speed patterns around a port. So looking at how trucks are moving, trains are moving, and then allowing that information to drive behavior such as rerouting of trucks. So what does the future look like? An incoming ship will trigger an alert after we auto-ingest a pilot berthing schedule. Equipment and yard space will be staged, rail cars will be pre-positioned, and computer vision will detect any issues at our gates and reroute trucks using GIS and other applications. We'll have smarter operations, lower emissions, and a cleaner, faster, more resilient supply chain. So I'm incredibly excited for what's ahead, not just because of our technology that's coming down the pipe, but because of the opportunity to build a logistics ecosystem that is more connected, intelligent, and secure. Thanks for your time today, and thanks to my partner, Sam Galltin. And so let's bring everybody back on stage for some Q&A.
Thank you, Nick and Samantha. That was a great kind of pulling together everything that we've been talking about today. A reminder to our attendees, please put your questions into the Q&A. We wanted to get started with the first question we have is from Catherine. Catherine wants to know, for leaf collection, has tree type or density and proximity been used to predict future leaf collection needs? I'm going to hand that off to Kevin and with the city of Hudson. We were talking backstage that you guys have a tremendous amount of data about trees. How do you use that data?
So yeah, currently we have all of our street trees are cataloged in our GIS system. So we know the types, diameters, heights, all that stuff. We don't catalog any private property trees. As far as tracking the type of tree density for leaves and stuff like that, we haven't made that move yet to track that information. One of the other challenges would be is to the level of participation that the residents may have those high leaf producing trees if they're going to participate, and to what level they're going to participate in. So it's really kind of it'll be an approach we may be taking, years out as far as tracking that information, as far as the volume of leaves that's produced.
Thanks, Kevin. I want to just kind of tee up while people type their questions. Remember, put your question in the Q&A, but kind of tee up to everybody. And we heard about leaves and snow, and we heard about containers, but I'm just kind of thinking about what are some of the other use cases for creating these really these really data informed solutions for keeping our constituents engaged. What do you guys see as new use cases coming up? Maybe Easton, if you have any thoughts on that, and maybe go to Nick and Samantha as well, and Paul and Kevin.
Yeah, I would say if we look at taking the data from the snapshots of the cameras, and then also how quickly you can build these if you already have the framework. So the example would be a quick launch like disaster relief map. So your constituents can see, let's say you're a county road commission, and I know there's one that a huge ice storm that just happened in Michigan, and they're dealing with hundreds of miles of just snapped trees. For residents to be able to see what the work is being done on those county roads that you typically would have no visibility unless you literally went out there to look at it yourself. That would be another use case. Another one that's sort of a typical operation would be like mosquito spraying for our friends in the South, right? It's a highly sensitive topic. If you have an organic farm, you have no spray requests, being able to share that information transparently and ensure that your residents are being treated equitably, or perhaps if you accidentally sprayed somewhere you weren't supposed to, you can then have that discussion. It's no longer, oh, I think I saw them spraying. It's like, yeah, you have the actual data. Kevin, Paul, do you have any thoughts on that?
Kind of building on what you had talked about there for a second, disaster response. We all get our storms from time to time. And I think we're working towards some sort of a method where we can start putting those plotting those points on a map. We'd mentioned with our electric utility and even the water utility, for whether it's a water main break or an outage, we'd like to get to a point where we've got an outage management or water type monitoring system where we're showing those points if there's a main break or an outage, where the trucks are actually responding to address those concerns. And that could be something that would be forward facing. So the residents, they know that we're working on their problem.
I mean, just to add, kind of use cases are really going to start to, they bubble up and you have no idea they're coming many times. I think whether it's a storm or whether it's something that happens in the community, it's something that's political, it's something that's environmental, you can never know what's going to happen. But what we are able to do are to define and kind of prep all your data collection systems, that they are primed to be able to gather that information. And the quicker you can get it, and the you have the processes or the staff or the tools to be able to kind of create something that's good and effective and that's informative to the residents, I think really goes a long way. I think to actually streamline the process to gather and get it back is where we really seem to get good feedback, whether it's from our city council or from our residents. It's a time anymore that the old way of doing things, where you would have something that happened, you would spend weeks and weeks to go and gather information and do the reports. No one has the patience for that anymore. And I think everything now is now. And I think that if you can connect those dots and set up all these different tool sets to produce something creative or productive and informative as quickly as you can, is what we're all striving for. It's very, very difficult because you can never know what's happened, but you have a pretty good idea. Here it's snowstorms, it's floods, it's hopefully not tornadoes, but they can come here too. But the kind of storms and the kind of things that we know are going to be impactful are the things that we can start to prep in order for us to get those tools, those gathering mechanisms in place. So whenever it happens, we can react and adapt quickly. So
Samantha and Nick, you both talked about all of these different data sources, and Nick, you were showing static cameras, but we were Easton was just talking about cameras, from dash cams and things. What are some use cases to pull together all of this integration of data coming from all these sources, and why are those going to matter to the people we serve?
Yeah, I'm pretty excited about something we were able to kind of stitch together once we kind of laid down, all the different data that is available, which is kind of driving environmental conversations, right? So the ability to validate that a container has been on a series of conveyances that are environmentally friendly, the ability to drive behavior in and out of a port from an environmental perspective to reduce emissions. And so when you start thinking about, we had the transaction information to be able to determine when a ship was leaving a port, say in Asia, to come over to California, we had that kind of heads up, hey, we're leaving. And, in for most regard, you don't know until they get within so many miles of our West Coast, when they're even going to come into that port and deliver those goods. And so what we were able to do now is actually leveraging GIS and other information feeds. We can track the speed and the route that ship takes across the Pacific and determine if that is an environmentally friendly maneuver. And so speed matters. The more fuel you burn, the more emissions you'll have. And these ships can actually steam at lower speeds and still make it to their destinations on time. And in doing so, we can measure the effectiveness of that environmental impact. We can measure the speed based on GIS analysis of when that ship gets a berthing appointment and comes into the port and actually berths with the dock. So we can determine whether or not they're steaming at the appropriate speeds to reduce emissions within the port. And then we're able to then track that container as it gets on that ship, off that ship, onto a train or truck or whatever that is, and knowing what those conveyances are, whether it be rail, which is a little bit more environmentally friendly than say a diesel powered truck, or even if it's a naturally gas powered truck, we can track all that out of the port now with the data that we have, and we can help validate to a Walmart or a Home Depot, hey, your goods and services, or your goods have moved through this entire supply chain up until this point on an environmentally friendly way. And I think that's going to really start driving behavior, bookings, and drive our industries in the transportation spaces to shift to a more environmentally responsible kind of way of moving our containers and goods.
Yeah, and I'd like to add on that too, as the transportation market as a whole. So you're talking ports, rail, trucks are all moving towards being more environmentally or lowering their carbon footprint, right? So that's in either going into electric vehicles or hydrogen. They're testing out all these different types of gas or whatever. But like that shift and understanding what that's doing for operations is data that we're going to have to collect and then try to compare. And so, like Nick's saying, validating what that actually looks like and seeing how the operations differ with electric yard tractors versus diesel and things like that, I think are going to be extremely important as we push forward to electrify a lot of our terminals and ports. And then two, I would also like to press towards automation. Like it's happening. It might be happening at a slower pace, but as we electrify and get to zero emissions, automation kind of starts coming with that. And so how do you automate terminals or even truck yards, things like that? You need a ton of data. You need to understand what's coming at you. How is that container coming at you? Is it coming at you with an automated truck, or is it coming at you with a person in it? All of those different things. And then how long has it been? How do we position it? Do you have to restack, take a container out of the bottom and put it at the top to make sure it's ready for that appointment? All of that stuff is data that needs to be translated and then transmitted to the next person so that the handoff is very clean, very quick, and very efficient. And then you can then top that off then with the lower carbon footprint of that. So I think those two things, moving in that environmental direction, but then also the automation piece, is going to be really, really crucial for all of this big data.
A reminder, please put your questions in the Q&A. One of the questions that we had came up from Andrew is, as we talk about all of this data, how well or not well was it received to implement tracking trucks among your public works and parks personnel? And how do you overcome roadblocks to the implementation of such a solution? So policy governance, what's the human side of that?
Yeah, I can field that one. So from our experience, we've had GPS devices in our trucks for probably the last 15 to 17 years. We recently, within the last 3 years, made a switch to a different product because the previous one, it was just basically every 5 minutes it gave you a point on a map and you could tell where the truck was. Since we've implemented the newer equipment, we've got camera capabilities, basically live feedback as to what the trucks are doing. We're getting all kinds of data back on the health of the truck. We can troubleshoot the trucks remotely and so on. So as far as how well it received, years back, there's a little bit of a pushback on it, but we implemented them in the supervisors' vehicles as well. So it was one of those, if it's good enough for us, it's good enough for you. We made it to where we weren't targeting them essentially. We rolled it out as this is more of a to protect you versus watch you. It's not that we didn't trust our guys. We just want to monitor where the trucks were. If we had a call from a resident that a truck was speeding, we can go back to that data and say, no, this truck was actually doing, under the speed limit. It was going here. And we get those types of calls on a regular basis. Since implementing the newer equipment with cameras and stuff, that was a little bit of a pushback when we started to put cameras in vehicles. And once again, we did the testing period in our supervisors first. We let the staff see how it worked. And they realize that we're not doing this to watch them. We don't have I'll call it the driver facing camera. We're just looking out the windshield. We've had a few cases where this has actually played into the benefit of the employee. And once they started realizing that, they've all welcomed the technology. We had an instance just this past winter where we had a gentleman call and he was pretty upset. He said that we almost hit his vehicle as we were plowing snow. Well, to give you a little background, it was a whiteout condition. We went back, looked at the footage because these cameras are always recording. Go back and pull clips up. We found that not only was our driver doing about 7 miles per hour under the speed limit, we found that this person actually pulled right out in front of our guy. So by having that information, we were able to basically come to the defense of our employee, point out that these were the parameters that actually happened. Based on video and hard data that we've collected. So when you start figuring those types of benefits in, the employees have been pretty welcoming of it from that point forward. I mean, this is probably I think our second or third year into the cameras, and they've wanted them in additional vehicles. So it's been very welcoming once they saw the benefit of it.
I think just one more thing to add to what Kevin mentioned too is that just so we're clear, the applications that we showed in our presentation, those are the public-facing applications, and we were very selective with the data that we are using to actually generate the maps and the layers that we're sharing publicly. But what Kevin's referring to as well is just the systems that we use to manage our operations. They are different and they're not publicly accessible. Because of the past, I think like anybody would have the initial pushback of I don't want to be seen by the public. It just doesn't look good. But by being very intelligent with the way that we extract the data, meaning we're only getting information that we want to gather in terms of the breadcrumb vision that we had, that's allowed us, and they're far more receptive to that. The stuff that we're sharing with the public is the stuff that the public want to see. So it's worked out quite well though, and it's only the last year where we've been able to do that. So
nice. Samantha and Nick, I was wondering, you guys talked about the harmony, like especially Nick talking about how do you do this thing, and you showed all of these different data sources, and some of these are from stakeholders that might be competitive with each other. So how do you build that trust? Any lessons learned about building the trust to be able to share this data and expose more of it?
So I'll start, Nick. I think it comes from first building the trust just as a customer, right? So myself working in the port, these were my stakeholders, and so me saying the message of, hey, this is how it's going to help, this is what it's going to do, I think first was the first piece, right? Of just saying, hey, trust me because I understand, but then also then showing them that one, their data was not going to be compromised. It's not going to be shown in a competitive nature. We're not going to share it with anyone that that would be able to use it for nefarious reasons, or your competitor, but then to bring in a trusted partner who is known to have that security, which was uncommon, right? So that built a lot of trust with ours. And then just like showing them in real time, here's what you're going to see and here's how it would help. So that buy-in factor was massive. Like just showing them, if you share your data with us, here's what we can link it up to, and here's the benefit to you, and then the bigger, broader community. I think, unfortunately, I think the bigger, broader community piece was like, yeah, that's great, but what can it do for me? And so when we showed them that benefit, that was an immediate like, okay, I get it, let's go, and we'll do it. But I will have to say there's also a carrot and stick part of this too, right? So that was the carrot, the benefit, the great. There were some people where we had to bring in with the stick. And, we used the tools that were available to us to be able to do that. But for the most part, once we showed the benefit, I think people got on board.
Yeah, I'll build a little bit upon that trust piece. Something I didn't anticipate. Like I had mentioned, we did a lot of work with the Department of Defense before working with the ports, and when we got engaged with the ports, one of the first calls that I had to field was from the president's supply chain envoy, because they wanted to validate that my company was capable of supporting such an important part of our national supply chain. And so that goes a long way when you then go and you start at the top and you have to now work down into the private industry pieces of it, and have them go, how do we know you're even legitimate? Well, let's start with, I just got vetted by the president. So that was a really good, helpful starting point for us. But additionally, just ensuring that we had an architecture in place. As I kind of walked through in our conversation, it was really important for us to lay out a plan, lay out the roadmap, show the different industry partners that we were going to segregate their data, but also show the parts and pieces of that data that needed to be combined in order for us to get the results that people were looking for. The other part of this was just so many people wanting everything to be better. I think in general, you always hope for the best, and that people really want to change things. And in this particular instance, it was that way. I remember one truck driving company kind of talking to me about the complexities of trying to drive onto a port, get a container, and drive off. And they have appointments, and they really do a really good job. They try to do a really good job of optimizing the ins and outs of the port. But in this particular example, the guy told me, he goes, look, I showed up on time, and next thing you know, I'm in a line of 100 trucks trying to get on the port. And it turned out that a little mom and pop shop with only a couple trucks was picking up a container, and their truck broke down in the middle of the gate, and they had no way of getting around this, and it just causes all these problems. And so the ability to leverage data to help, in those specific situations, right? How can we reroute you? Can we open, a backup gate? Can we move containers to a different location while we work through that problem? All those types of benefits there. Once we kind of start walking through those benefits with folks, as Sam mentioned, people just started lining up, and they wanted to, find ways of making it better and improving the port operations.
That's awesome. We have one question in the Q&A. I want to direct this at Easton. So Joe wants to know, speaking about, Nick was just speaking about benefits. What are the benefits that somebody might see from doing applications like this in park and recreation area?
Oh yeah, well, sure. So public park and recreation, my dream piece of equipment, and I haven't done it yet, I predominantly work in upper Midwest, is to install a Samsara gateway on a Zamboni, because I think it would be so cool to have an ice map, not a snow and ice map, just an ice map, so you can see like, hey, they just Zamboni the thing, let's go skate. That would be excellent. But unfortunately, I haven't gotten my hands on a Zamboni yet. Some of the other applications would be like, mowing, like that's very important. Cities take care of a bunch of mowing, not only knowing like, hey, when was the last time we actually did this, but perhaps if you're concerned about ticks and tall grasses and things of that nature, when is a safe time to bring my kids out and play in this park? I want to do it after a mowing event and maybe a week later. So yeah, things like that. I don't know, one of my pet projects I'm really looking forward to building, and I haven't built it yet, but from a sustainability aspect, I'm an environmental engineer by trade. How can cities and parks understand how they're spreading their salt effectively, specifically for environmentally sensitive areas? So I was talking to the city of Fort Collins where I live, and their city engineer was telling me that maybe they spend like $40,000 on this beautiful stormwater retention basin. These little native plants just try their hardest. They're poking through the grass. The winter comes, salt truck drives by, and boom, like kills all the plants, and they have to plant them all again the next season. So how can we basically split up like essentially the water basins, floodplains essentially, of what your salt looks like, and then how can we reduce that chloride that you're putting into the environment? So really, it's just like, yeah, you have data on vehicles, data on salt, data on safety, and there's just a bunch of interesting questions you can start to answer with those.
Nick, can you talk a little bit, when you think about this port work, and like how does the Mark is asking in the Q&A, what are the data challenges that come up from the supply chain crises? So we had the pandemic supply chain crisis with all of the congestion, which initially got you started working on this, but you had a lot of experience before that. Now we have a different problem where there's a dearth of vessels in the ports, and that's going to have some ripple effects. Talk a little bit about what the data challenges are, as for these ports as they relate to local communities around them.
Yeah, I think the biggest thing that we saw was the privacy concerns, the proprietary information concerns that reside within each industry, right? So when you look at a port, you've got an ocean carrier company, you've got a terminal operating company, you've got a truck driving company, a rail company. All of those companies have their own data. They're all being hired either by a third-party logistics provider or by a specific customer, right? So your big box stores and things like that. And so they protect that data because, obviously, Walmart and, a competitor, they don't want people to know what's moving through that port, or they don't want Amazon to know what's happening with their supply chain. And so there's a lot of kind of barriers to getting that data. And then when you look at the impact it has, because everybody's so protective of that data, and those silos of data gets created, is you're unable to coordinate with other parties that are probably interested, but maybe not directly able to get to the data specifically. And so what we're trying to do is break down all those barriers, and we've done that by creating kind of a new data format that we're trying to work to get it adopted across the country, that gives the people the information they need to know when they need to know it at the exact time that they can get it. And so breaking that down, getting that security in place, and ensuring that we can kind of lower those barriers to information was one of the biggest challenges, because you have so many people with their hand in the pot, and making sure that every one of them's happy, including regulators, right? So the federal government, the state government wants a part of this, the local municipalities want a part of this. So there's just a lot of people at the table, and so navigating all those different, I guess you could say, opinions was one of the hardest parts of working in the port.
Thanks, Nick. Ricardo has some questions about the breadcrumbs that we've been talking about. How does the data get how does that get collected? Does the driver actually have to initiate collecting some data? Is this collected automatically and sent through IoT devices? Talk a little bit about how these data points would, I think Kevin, Paul, and Easton, you are all talking about these breadcrumbs. Talk about how those breadcrumbs are collected, and maybe how what the thought process is in determining what you collect or how you use it.
Paul, you want to take that one, or you want me to?
Yeah, I can take it, and you can fill in anything that I missed. So the data collection process is it depends on which application we want to collect it for. It is a little different for the leaf collection application, we had to, with Kevin's help and his team, we were able to make sure that when we were putting points and gathering points, it was only when the leaf vacuum was operational, just because that is the real focus of the application, to actually show residents where the leaf apparatus is actually being used. They're attached to trucks, and we have GPS of the trucks. But what was really important about the use of that application, or the purpose of that application, was to just drop those breadcrumbs every 5 seconds whenever the leaf vacuum was actually turned on. And Kevin and his knowledge of like hardware and his intelligence on how he can do all those things, which he's kind of our MacGyver for all those types of things inside of the city, we're able to figure that out, and it worked really well. It's a little different on the snow side of things, just because it's their internal equipment to the actual salt spreader. So the salt spreader, when it's turned on, is when we're dropping down breadcrumbs or we're dropping down salt. And whenever it's not on, we're not gathering information. So it was really kind of showing the public and using a combination of just the equipment and when it's dropping points and how we gathered it. Because we don't want to just be gathering countless points, because when you're monitoring, I think it's, how many trucks do we have, Kevin? Is it 15?
15.
Yeah, 15 trucks. When you have 15 trucks and they're dropping points down every 5 seconds for long storms, that starts to gather a lot of points. Doesn't sound like a lot, but it does. And then in order to actually use that and put it on a map that's not really, really slow and it's not lagging, all those things have to be considered to actually show something at the end, which is really simple to use and read, because it's just showing the breadcrumbs. Hopefully that answers the question. Kevin, is there anything else you'd want to fill in there?
Just to kind of build on what you had said, Paul, is on the Leaf app, Paul had also put in some parameters that won't capture the breadcrumbs if they're going over, let's say, 5 miles per hour, because we know people aren't out there walking next to the leaf axe collecting leaves beyond that speed. We also put in some geofences, so we're not seeing areas where the trucks are either sitting at the shop or at the dump location. To put another little touch on the question, is it manual or is it, the IoT? It's kind of both. It's initiated by the driver by turning on a switch or turning on the device. From that point forward, it's done through code that Paul's written, and the device actually putting information into the database. So the device is putting information to the database, and Paul is filtering that out through code. So it's kind of a combination of a few different things. On the salt, as you mentioned, we were tracking based on the spraying of salt. So they'll have their equipment turned on, but until that salt spinner starts distributing salt, we're not recording their location. So those are the only things I had to add to it.
Easton, I was wondering if you could add to that a little bit. I would imagine, there's all of this data that's being collected in a place like Hudson. We just talked about how much data they're collecting. Do you see at a systemic level, and maybe Nick, maybe you can also speak to this, like what are the opportunities to establish benchmarks or to actually be able to tell people what's going on and how one community is different than another community? Is there valuable information that can be generated?
Yeah, I can speak to that. So Samsara has trillions of data points, and we store all of that. As long as you're a customer, you have access to your data, unless you have specific data retention requirements. Anyways, we have a lot of data and we know who these customers are. So what we're able to do with that is create reports, kind of just like what you said, they're just benchmark reports. So if you're a city or you're a municipality and you're like, I have a sustainability goal, but I don't know how I'm doing. Like, I don't want to spend half an afternoon talking to all these cities and saying like, let me see your sustainability report. Like, how are we doing? Like, it's sort of looking at data through a secondary lens. Well, Samsara is measuring that sustainability, maybe that's CO2 emissions or the idling or perhaps the safety, and we are can conglomerate you in your group. So the city of Hudson would then be combined with the many hundreds of cities that are their size and have fleets about their same size, and then they can see themselves on that graph. Like, hey, we actually are doing very well on our sustainability, but we have some work to do with our safety aspect. So you're no longer looking at yourself in just a vacuum and trying to just beat your head against the wall meeting some random goal. You can actually look at that data in context to your peers.
Nick,
Yeah.
any thoughts from you on that?
Yeah, I'll just add, I think where we've seen the most impact is, there's a lot of pressure on the West Coast sports to maintain certain environmental standards. And so we were able to, there's an element of, fuzzy math there that was happening, in order for them to achieve, where they wanted to go and try to figure out the reporting, a combination of several different products. And when we were able to come through the middle there, once we brought in this additional layer of data integration, kind of what Easton was talking about is all of a sudden now you have all of the data to validate that you are doing, CO2 emission monitoring correctly. We can validate that we set a ship, did something, and therefore the emission should be about this. But, we have the speed. We know the course it took. We know how long it was sitting idle or before it was plugged into electric generation. And so, we can really quickly validate and provide that given all the different information that we're able to collect. And I think we're really just kind of scratching the surface, because what we really want to do now is start looking at ingress egress of, say, like trucking companies, coming in, and we can tell based on using computer vision, what the tractors are, or, is it a natural gas tractor or is it some other fuel type? And you can really start, honing in on the types of emission, capabilities and calculations that are happening as we track those trucks and their routes and be able to use the data, to have additional impacts from the environmental perspective.
Easton, thanks, Nick. Easton, can you talk a little bit about how you integrate with the various systems? So from Samsara, you guys have a very robust platform and everything, but Kevin and Paul were talking about Esri. We've been talking about a lot of other integrations. Talk a little bit about how people can think about integrating with systems to do these kinds of things, because what we're starting to hear is that this is collecting data from one place and being able to integrate it to provide new information, new value. Talk a little bit about the realities of that integration.
Yeah, definitely. I think even taking a step back from the integrations, it's more a question of like, what are you trying to get done? Like that's Samsara's big thing is like, yeah, what are you really doing here? Like, are we just collecting data just cause, or do you actually have something you want to do? And then it's like, all right, what do we have existing in our fleet, or perhaps in our technology stack? And is this just providing us data, maybe historically, maybe slowly, like Kevin and Paul said? And then if let's say it's reporting data, fine, it's reporting data at a pace you would like, is it able to then connect to other systems? And that's really where Samsara does a great job. All of the data that you saw from Paul and the information that he built was built off of our open API. And anyone can go to that website right now. Like we don't hold that behind some gated door. It's very, very clear technological, basically instructions for how to start connecting to that data. And if you have something like Samsara where you have the keys to your castle of data, you can do whatever you'd like with it. Now that's sort of the custom route. The integration systems that municipalities typically do in-house with existing already kind of pre-built integrations would be things like AssetWorks. We mentioned Esri, we didn't mention, but company Fleetio for sort of tracking work orders in-house. So yeah, start top down. What are you trying to do? What do you have? Do we need to build something customers or something already existing? And yeah, just move from there. So
Paul, any thoughts on integration from your perspective? Do you have a wish list of what you'd like to be starting to look at, how to use this data?
Well, I think what Easton touched on is exactly correct. That unless you have a true purpose for the integration, it's not really worth doing. I think many of the different types of systems that you may want to integrate, at least the Samsara data that we've got, it's really GPS data, and I think as long as it is provided in a format or in a way that is accessible, and it is a really simple, publicly accessible and privately accessible API to be able to extract the information that you need. you can as long as you get it clean within your own system, you can put it in whatever kind of system you would like. That sounds pretty straightforward and logic, but it's true. I mean, if you're using the main, like the simple lat long for the GPS locations, if you have just basic simple mechanisms to interpret how each of the types of data are defined, as long as you can drop it in a SQL table or any kind of database table, allows you to really take that data and put it wherever it would like to go. I mean, as APIs go, I think most applications or most products, most vendors that generate data have found the fact that the API is the way to go. I think nowhere is in a vacuum anymore. And I think with the emergence of AI and the LLMs that you can have access to in order to make models intelligent, the more access and the more easy to use APIs are really what are going to benefit vendors. So they know as soon as they build whatever that application is, that it has to be accessible through other mechanisms. Otherwise, they spend a lot of time and money in professional services to integrate their systems with another product. It's far easier from the vendor's perspective if it's just open and everybody can go and access it. I think what we found over the course of the last several years is those APIs are really well written now, because that professional services hurdle is something that folks just don't want to mess with anymore. It's just far easier to say, what do you want to do? Here is our data. And if we want to access that data, can I give it to our developers and have a level of confidence that they can go in there and interpret and extract what they need? That's what everybody's pursuing at this point. I think that goes right across the board with whatever kind of data that you're pushing to the public or to vendors. The easier it is to access, the better it can be used for everything. So
That's great. That's our time for today. I want to thank all of our presenters. These sessions are all recorded. You registered for this, so you'll get an email about how to access the recording. I'm sure anybody on here would be happy to connect via LinkedIn or by email if you have their email addresses. Just want to thank you all for the opportunity to learn with you. This has been part of the ongoing series about GIS and AI for local government compliance and asset management. And really want to thank Connect Me Events for having us today. And thank you so much. I hope everybody has a great rest of your day.